All right, sorry about that. My phone ran out of memory, so I had to delete a whole bunch of stuff. But we almost there. I was hoping I could film that whole section in one shot. It didn't work, so I should always split it. So either way, so basically is what we learned back in chapter 3, right? Plug in the money, plug in the numbers that were given. Or the same way, you can start with this new formula, and you get the same thing, of course. E to the what? Negative 0.05 times 10, which is exactly what you would have if you divide both sides by the E value. So put this in one shot in your calculator, and you don't have to divide or anything. And you're going to come up with $60,653.00. Okay. Now, how are these instructions going to change so I know that now I'm supposed to use an integral? So it says, find the accumulated present value and future value of an investment over a 10-year period if there is there you go, continuous money flow of $2,700 per year. So there's a continuous money flow. It's not like you started with an amount and just left it there and went on vacation and came back 10 years later to see what happened to it, right? There's a continuous money flow of $2,700 per year. And the current interest rate is 9% compounded continuously. Yes. Okay. So how do I find the future value, and how do you find the present value? Either one of them, we had the two formulas. So I'm going to find the future value. I think we called it PF. So that's going to be the integral from now until how many years later? 10-year period, yes? Okay. Of C of t, again, what do we have? We have a principal, right? It's P e to the RT. That's what I'd have to put in. Except for a P is not a fixed amount, and then we leave it there for 10 years. But we're getting 2,700 per year. That's your C of t. That's the continuous flow. It's constant, but it's per year, right? So every 1 year, 2,700. Every 1 year, 2,700. After 1 year, after 2 years, you just keep adding on 2,700, January 1st, let's say, of every year for 10 years. E to the 0.09 t dt. Okay, so we can do that because this is a constant. Sometimes these values can change, and we could have that's what we're going to do in section 5.9. We're going to put a variable here, make this a true function. Well, not a constant function, right? But then we don't know how to take the antiderivative of a product. We would if we just simply have a coefficient, right? If it's just a number, we get to keep the number. But if this would come with a t itself, we wouldn't know just yet what to do. So we keep the 2,700. It's the e to the 0.09 t divided by 0.09, evaluated between what? 0 and 10. So I'm going to mess with that a little bit. I'm going to divide by 0.09. So I'm going to get 30,000 e to the 0.09 t, plug in a 0 and plug in a 10. So that's 30,000 e to the 0.9, right? I plugged in the 10, minus 30,000 e to the 0, by the way. And what's e to the 0? That's a 1, right? So minus 30,000. So put that in your calculator, and you're going to come up with a $43,788.09. So if you just put in 2,700 per year, yes, for 10 years, at this pretty good interest rate, but again, you have to keep adding on the 2,700, yes? After 10 years, you get that. What if this money wasn't invested? How much money did you actually put in? 2,700 every year for 10 years. So that makes it 27,000, yes? So the 27,000 really grew to 43,788, except for you didn't have your 2,700 at the beginning, right? That's who has a bunch of money laying around and let me just invest it, put it all there, right? We just put piece by piece, right? So the present value, I'm just going to use the formula, the integral formula. what did we call present value? P, I'm just, it's just notation, who cares, present value, P, oh, PV, present value, okay, fine. It's just your P. It's the integral from 0 to 10 of 2700 e to the what? Negative 0.09 t dt. So the antiderivative of that is 2700, keep the 2700, e to the negative 0.09 t divided by negative 0.09. Plug in a 10 and plug in a 0. So that's, again, the 30,000 e to the negative 0.9 minus, oops, that's a negative, negative 30,000 e to the 0, right? Okay, so that's going to be a 1. That's going to be a positive 30,000, and you're taking a little bit away. So what you're going to get is $17,802.91. What does that mean? This is what it means. If you put in every year 2,700, yes, for 10 years. So again, the first year you have 2,700. The next year you have 2,700, so you basically put in 5,400, yes? So far, after the third year, another 2,700, so that's what, $8,100 that you put in so far, and you keep adding that on. At the end of the time, you're going to come up, at the end of 10 years, you're going to come up with this sum of money, right? What we figured out here is basically what? What lump sum of money would you have had to invest now in order to come up with the same amount in the future? So you would have had to have $17,000, 802.91 sitting there, and you put it in now at the beginning. Now, again, who has 17,000 just laying around? Of course, the 17,000 is less than the 2,700, right, that you actually have to invest. But remember, you're not putting it in all at the same time. At the beginning, only the 2,700 grows for the first year, right? The second year, the 5,400 grows, right? And so on and so on. So that's the amount of money that you would have to have lying around right now. Put it in for 10 years to get you the same amount, okay? Sure enough, it's nice. Now let's check. What am I checking? What I'm checking is this. If I invest $17,802.91 right now, and I leave it at 9% interest rate for 10 years, how much money would I get? I'm gonna have you put this in your calculator and see what you're gonna come up with. I already know the answer without my calculator. What is my answer going to be? It's gonna be 43,788.09. Okay, so what we could have done, as I said, is you didn't have to compute both integrals, right? All you do is either find the present value, plug it into this formula, and then that's your future value, yes, out of this formula. Or you could have found your future value right here, right? Plug this in, just use this simple equation right here, and that gives you back your present value, right? So I just wanted to do both just to show you how actually it does come up to be the same, but you didn't have to. Okay, so this is your section 5.6. Now, there's a nice homework question there about what? About present value, future value. What this is kind of like used for is, let's say, hey, again, I don't have this kind of money laying around, but let's say I want to buy a company that's going to produce me this amount in the future, right? Every year, my company, there's a problem in your homework, that this company is producing this amount, right, of money every year, right? But I have to spend this $100,000 on it right now. Is it worth me, right? So is that a true present value? If I would have had 100,000 right now, could I come up with that amount of money in the future? So I'll let you do that homework and ask questions. So that's that.